Good day, everyone. Our most essential learning competency for today is determine whether a function is continuous at a given number or not. Three conditions of continuity. A function f of x is continuous at x equals c if and only if the following conditions are satisfied. A. F of c is defined. C there is, of course, constant. B. The limit of f of x as x approaches c exists. Letter C. The limit of f of x as x approaches c is equal to f of c. So the given c here is 1. So this is f of 1 is equal to 3 times 1 minus 1. We just replace x by, of course, 1. That's how we evaluate the function. 3 minus 1. So f of 1 is equal to 2. Therefore, we can say that f of c is satisfied. F of c is defined. Now, what about the second? The limit of f of x as x approaches, of course, c, which is 1, is equal to the value 3x minus 1. We replace x by 1, so this is 3 times 1 minus 1. This is 3 minus 1, and this one is 2. So therefore, the limit exists. So, condition number 2 is satisfied. What about the third? Limit of f of x. The limit of f of x as x approaches 1 is equal to f of c. So this one is equal to 2, and this one is also equal to 2. Therefore, we can say that the function f of x is continuous at x equals 1. Example number 2. F of x equals 3x squared minus 4x plus 1 over x minus 1. The given c is 1. So, let us evaluate f of c. So this is f of 1. 3 times 1 squared minus 4 times 1 plus 1. This one is 1 minus 1. So f of 1 is equal to 3 times 1 minus 4 plus 1 over 0. So any number divided by 0 is undefined. So this is f of 1. What about letter B? The limit of f of x, the given f of x is, of course, 3x squared minus 4x plus 1 over x minus 1. So this is as x approaches 1. So if we'll simplify it, get the limit of this. This one is factorable as 3x minus 1 and, of course, x minus 1. So this is x minus 1. We can cancel this, and therefore this is 3x minus 1. Replacing x by 1 here, this is 3 times 1 minus 1 equals 3 minus 1. This is equivalent to, of course, 2. So therefore, we can say that limit of f of x as x approaches 1 is equal to 2. From there, we compare the two. Limit of f of x as x approaches 1 is equal to 2. And that is not equal to, of course, f of c, which is undefined. Therefore, we can say that the function is not continuous at x is equal to 1. Example number 3. F of x is equal to 1 over x. X is equal to 0, so our c is 0. Let us evaluate f of 0, that is 1 over 0, and f of 0 is undefined. We can say that f of c is not defined already, therefore, will not be doing b and c anymore. Okay, so meaning at x equals 0, the function is discontinuous. Number 4, we have f of x is equal to x cubed plus x squared minus 2 x is equal to 1. So our c is equal to 1. We will be replacing all x's by 1. This is 1 cubed plus 1 squared minus 2. 1 cubed plus 1 cubed is 2 minus 2. F of 1 is equal to 0. So our f of 1 is equal to 0 and that is defined. What about the second? The limit of f of x as x approaches 1 is equal to x cubed plus x squared minus 2. Replacing all x's by 1, we have 1 cubed plus 1 squared minus 2. We have 1 cubed plus 1 squared is 2 minus 2. This one is 0. So the limit, we can say that the function is continuous at x equals 1 because the limit of f of x as x approaches 1 is equal to 0, and that is also equal to f of c. The three conditions are satisfied. Number 5. We have f of x is equal to 4 over square root of 4 minus x. Our c here is equal to 0. So this is f of 0 equals 4 square root of 4 minus 0. So f of 0 is equal to 4 over square root of 4. This is 4 over 2. F of 0 is equal to 2. So f of c is defined. What about the second condition? We have limit of f of x as x approaches 0 is equal to 4 over square root of 4 minus x. Okay, so let us rationalize this first. This is 4 over square root of 4 minus x times square root of 4 minus x, square root of 4 minus x. So this is equivalent to 4 square root of 4 minus x over 4 minus x. Now, we replace all x's by 0. So this is 4 square root of 4 minus 0, 4 minus 0. So this one is square root of 4 minus 0 is of course 4. Square root of 4 is 2 times 4 is 8. 4 minus 0 is 4. So therefore this one is equal to 2. Now, our limit of f of x as x approaches 0 is equal to of course f of c, since this one is 0 and this one is 2 rather, and this one is. The three conditions are satisfied, therefore we can say that the function is continuous at x equals. Example number 6. We have here a piecewise function f of x plus 1 if x is less than 4, quantity x minus 4 squared plus 3 if x is greater than or equal to 4. So our c is 4. So f of 4 is equal to, we will be using of course the second expression since the condition is x is greater than or equal to 4. So this one is 4 minus 4 squared plus 3. So this is f of 4 is equivalent to 0 squared plus 3. So this one is f of 4 equals 3. Therefore, we can say that, of course, f of c is defined. What about the limit? The limit of f of x as x approaches 4. This is equivalent to x plus 1. So we have here 4 plus 1 is equal to 5. And then the other one, we have quantity x minus 4 squared plus 3. This is equivalent to 4 minus 4 squared plus 3. So we have here 0 plus 3, it's 3. So the second has these two values. We have 5 and 3. Now, is C satisfied? Is condition C satisfied? We can say that condition C is not satisfied because f of C is 3 and our limit of f of x as x approaches 4 is 5, and of course 3. Okay, so they are not equal. So if that is the case, we can therefore say that the piecewise function is not continuous at x is equal to 4.